Today I'm looking at the question of how you bring real-time responses into serverless web front-ends. This is a bit of a tricky concept because often serverless is equated with event-driven programming and the idea that some event has to trigger the code to do something. And to do things in real time, often that means you need WebSockets, which means you need a server, so that's not serverless. But we do have some options that we can use, and I wanted to show you some of those today. So I wrote this article last week that's had a few responses, and I just wanted to go through it in some more detail. There's a tricky class of calls, which I talk about here, where if you follow this example, you might have some front-end code that calls API Gateway, DynamoDB, kicks off a stream, fires a Lambda function, and the result from that Lambda function effectively disappears. There's nowhere for it to go upstream back to the front end. So how do you get this call back to the calling application? There are a couple of solutions I discussed that's just worth just looking at. The first option in many of these cases is to wait. This is really the standard default way of doing things. Your front end calls an API gateway code and it simply waits for as long as it needs to. Now the limitation here is that API gateway will only let you wait for 30 seconds before it times out, so that can be a problem. But for simple solutions where you don't have many users, some internal scripts, this is by far the easiest way to manage the problem. The second way to approach this is polling. And again, this is very common. So what happens here is the front end calls API gateway, which calls a Lambda function. This immediately acknowledges the request with an ID saying, I've got the request, everything's fine, while it goes off and does the work further downstream. So API gateway at the top here responds back to that initial request. The front end at that point polls on some periodic basis every second, 2 seconds, or whatever the case may be, to check what the status of the job is. So in this case, you might be storing the status in DynamoDB. It's a common way to do this, and your API gateway call is simply checking that table to see if the work is ready. This is fine too, especially in fairly low usage case examples, but it's a little bit inefficient. If you're waiting 20-30 seconds, you might be making 20 or 30 calls to see if the work has been done, when you just really need to know when it's been finished in the end. So this introduces this idea of, well, we can use publish subscribe. So pub sub has been around really forever, but it's typically used for more complex applications, things like market data in trading applications, which is where I know it from. And what this basically says is that the front end makes a subscription to a topic, and then it leaves that connection open, and the back end somewhere, when information changes, it publishes to that topic, and through the mechanics of pub sub, the front end gets an immediate alert that something has changed. Now, in the serverless world with AWS, we have IoT, which is perfectly capable of doing this. This puts a lot of people off because IoT sounds complicated. It's the Internet of Things, and it doesn't sound like it's really something to do with serverless applications. But actually, it works really well. It's really just a wrapper for an MQTT, which is a lightweight messaging protocol to push these messages around. And it manages a lot of the complexity for us, which is, of course, in serverless, something that we really like. So I wanted to show you how you can bring real-time to your front end with about 100 lines of code. And of that code, most of it is boilerplate. So first of all, we're going to download the code in the article, and from this URL, that helps you make that happen. To get a copy of the code, all you need to do is clone my repo. So just do a git clone with this URL, and it'll copy down everything that you need. If you cd into that directory, just type npm install, and that will install all the various packages to make it run. Okay, that's done, and now if I open this in VS Code, you'll see this fairly large number of files, but it's not too scary. Most of these we don't care about. They're boilerplate just for this view application that runs the example. The two we do care about are these ones here, iot.view and app.view. So before we get into this, we need to set up the backend to enable the real-time messaging to happen. So let's go to the Iot Console. There's a few steps you have to complete here. So just click on Manage, and then Things, and then Register a thing. Create a single thing. I'm just going to call this Ask James. and then create a certificate. And just take a note of this message. It's going to take a few minutes to push out all the changes needed to make this work. And when that's ready, you'll see a screen that gives you an ARN for your thing. Next, we need to go to Cognito. Cognito alarms people, and it's a scary topic, but it doesn't have to be. In this case, we're just creating an empty pool to use for our application. So just hit create a user pool. We're going to give it a name, Ask James, review defaults, and create the pool. This will give us a pool ID we can use for our application as well. So take a note of this pool ID. Yours will obviously be different. So the two things you need to have written down at this point are your pool ID and your ARN from IoT Core. Then if we go back to the code, we just plug in those two values into here. So this is your IoT Core ARN, and here is your pool ID. Yours might be a bit shorter, it just depends on, they've changed the format in the last few months. Make sure obviously this matches whichever region you were in. I switched regions in the example just because mine is currently running on US East 1. Now once you've put in these details, all we have to do then is say npm run dev. Okay, now that's installed everything and running, you'll see that there's a URL here. If we just go to this localhost URL, you can see the application is waiting. Now back in AWS, if you go to the IoT Core page, on the left hand side there's an option to test. If you scroll down, you'll see you can publish messages. So our topic is Ask James, and we just put in a message here, it can be anything, and then hit publish. And you'll see immediately over here that the front end has received that message. And I'll do it again. And again, it's over here. So what's happening here? Well, back in the code, this is a lot of boilerplate code that I took from the IoT Core developer site. And really very little of it's been modified to make it work with the Vue.js application. You add in your pool ID and your host. Specify unique client ID, so we're using a random number here, and then essentially it just subscribes to the topic using this MQTT client. Now the nice thing about this is that a lot of the difficult parts of retry logic and multi-day management, if you leave the window open, are all handled for you, and it scales to thousands of users or even millions of users potentially without you needing to change your code. Now in real life, you're going to find that you're not sending messages this way using a test platform. You'll be wanting to send code from your Lambda functions. So how do you do that? In the code base, there's a backend sample file that gives you an idea, and it's remarkably easy. You just need to call the IoT data library with your endpoint, and then pass your topic and your message. So as a quick example here, in Lambda, I just created a simple function called publish IoT, where I've used similar code. I've used ES6 syntax here, but all this is going to do is publish to this topic, this payload hired from Lambda. So if I open this over here and then test, you'll see that message appears in that window. So it's really that simple, and this is perfect for dashboards or any sort of web page or web app where you need to have some sort of connection to real-time data going on the back end, or you have functions that take a long time to complete and you need to find a way of getting around the 30-second timeout in the gateway. Now there are all sorts of alternatives to this. There's third-party libraries like Pusher that you can use. There's also API Gateway Websockets. The main difference with WebSockets is that with API Gateway, you have to manage the connection information. So if you have a large number of users, that can involve putting those in DynamoDB, so it's a bit more complicated to manage. This solution is really out of the box, ready to go. And although it seems a bit strange using IoT for the solution, it's a really dependable mechanism. We've used it for a number of different applications with fairly large numbers of users. Cost-wise is extremely cheap, so you're looking at something like 8 cents per million connection minutes and $1 per billion messages. So it's a fairly manageable cost until you get to web scale. So that's my run through. I hope that was useful. If so, don't forget to subscribe to my channel.